Hello everyone. This is probably our first video you're going to see. I did some tests that you're not going to see that didn't come out very well, but we've worked out all the bugs. Before we start moving forward, this video will be a review. I've had a lot of questions over writing a function rule. So let's write a function rule for a nonlinear function. You may remember on page 248 we did the problems with those cubes. Now you know for sure I'm not going to try to look at those cubes, but basically it was a cube. Whoa, way over off. Let's try that again. Over here we had one cube, and then we had, that's a cube of course, not a square. But if you look on page 248, the diagram will be a lot better. And then we had two cubes. And those two cubes represented actually 4 on that level. And if you look at page 248, the diagram will be much clearer. But what I'm going to do is, let's go ahead and let's get that table set up. Again, the table is explained. Again, we're looking at problem number 2. Problem number 2 on page 248. And when we analyzed that cube problem, we saw that the number of blocks on an edge, that means if we're looking at the blocks, because all these blocks were put together to make a bigger block. So if it had one block on the edge, number of blocks on edge. And I guess the key is to know, what does that mean, the numbers of blocks on an edge? Well, that's kind of giving you the width of that cube, the width or an edge or a side, whatever you want to call it. We'll call it the width or side, since it is a cube. And by now, we've done this in class once before. You realize that what we're talking about here is the volume of this set of cubes that are, when they're put together, make this bigger block. So that's the first thing. And this is going to be our x value, in case you haven't seen that already. That's going to be our x value. And then on the other column, it's the total number of blocks. Well, the total number of blocks is nothing more than our volume. The volume, total number of blocks. And that's really our volume. And that's going to be the y value. And if you look at a block, a block like that, and again, I'm going to do my best to draw this so you can visualize it. If you're looking at this block, and I tell you this block is 4 units wide. Forget the units with there. It's 4 units wide, and it's 4 units this way, and it's 4 units that way. Well, 4 times 4 is 16, so this is 14 square units at this level. But since it's got 4 units more, it's got 1, 2, 3, 4. It's 16 times 4. And that equals 64. So the volume of this whole entire thing is 64. So here they'll give us one single cube, and it has a volume or a total number of cubes. Because again, they chose to use the number 1 and 1 for the value, and they didn't give us a unit of measure. So the edge and the number of blocks is the same thing. And then over here, it's 2 on the edge. Well, imagine that 2 on one floor is 4, and then there's 2 floors, so there's a total of 8 blocks. And then there's 3 on the edge. 3 times 3 is 9, times 3 is 27. And basically by now, as many as they want to give us, we can pretty much predict what it is. 4 times 4 is 16, times 4 is 64. 5 times 5 is 25, times 5 is 125 total blocks or the volume of that shape. Well, I'm getting some crazy streaks in. I'm sorry about that. So now we have that. We've got to get a rule that satisfies that. Now, the book doesn't go ahead and give us this information yet, but I'm going to go ahead and let you in on a little secret. Let's take a quick peek. Let's get a color change in here. And let's look at the difference real quick. Let's identify whether this is linear or nonlinear. Of course, by the title of our paragraph here, you see that this is nonlinear. The difference between 1 and 8 is 7. 19. Difference between that is, and the difference between 27 and 64 is 37. And the difference between 125 and 64 is we're going to add 61 to that. Now you're seeing that the difference changes and it also increases. But the difference changes, which tells us that this is not a linear function. This will not create a straight line or a line. This will be a curve when we graph this out. Now, let's go ahead and let's find the rule. I told you early on that I'm going to let you on a little secret. Whenever you graph a line, and let's just put this over here real quick, just so you can see it. If we're graphing a line, the greatest power of the variable will be x to the first power, or just x. That will be linear. When anything is a curve, and then we'll look over here, we'll put a blue in here, and it's a curve, such as this one is, that's going to be x to some power n, where n is greater than 1. In other words, for there to be a curve, the exponent on the x, or the exponent in the equation, has to be greater than 1. So I guess what they want us to do is go ahead and figure out real quick what a good equation is. So let's look at the second one here, and let's try and figure something out. If we have an x value that equals 2 and a y value that is 8, how do we go from 2 to 8? Well, we can say 2 times 4 is 8. We can say 2 plus 6 is 8. That's one way. And another way, it's a little bit more obscure. It's not that common to us. It's basically if we take the value of x, in this case 2, and we raise it to the third power. In other words, 2 times 2 times 2, and that equals 8 also. Now, later on, when we start getting a little bit more advanced, immediately you'll be able to tell that these two choices are no good. Those two choices are no good because all of the powers here are 1. They're all power 1. So by default, it's got to be this one. But let's go to just test one out just to be sure. Let's look at 5. Well, 5 plus 6 is 11. Nowhere close to 125. 5 times 4 is 20. Again, nowhere close to 25. But 5 to the third power is 5 times 5 times 5 equals 125. So it's safe to say that we found the equation for our graph. And that's going to be y is equal to x to the third power. In other words, whatever you put in for x raised to the third power will get you the y value. Now let's pause this just for a second. I'm going to get a fresh page. Okay, I didn't want to spend a lot of time drawing the graph here without you guys, but I will start now that I'm starting to plot. So let's take a look at what we've done so far. We've got a graph where the x values, this is going to be the number of blocks on the edge. And this is total blocks. And then now we're going to go ahead and just plot the points we have. The points that we had was if at 1, 1, it's right there. The next one is 2, 8, so it's just below the 10, right over there. The next one is 3, 27. It's 3 is there, just approximately just below 27. And you see that curve starting to come in already. 4 is 64, so that's going to be up here between the 60 and the 70. And then finally the 5 is going to be between the 130 and the 120. And that's going to be way up over there. Now, no one's talked about lines yet, or curves or anything, but let's just go ahead and get an idea what this thing would look like. And I'm just going to do a little bit of lighter color. And you see if we just come over here and we match these up a little bit. And again, we're not supposed to do is just plot the points. Oh, I'm getting a little curved. I'm sorry. We see that what we get is this curvy looking thing. And later on you'll see that this is a pretty common curve for y equals x to the third power. This is the curve of y equals x to the third power. And it behaves one way over here. And then as it crosses, it'll equal 0, 0 over here. And then it does something else entirely different on the other side. But we'll discuss that later on. I hope that helped. And again, go through the other videos. I'll find other sources to post for you to get more examples. And then stick around because I'm going to do section 4-4 in a few minutes.